Evening students, welcome to the class of Technomaths. So today we have taken one question. Okay, the question is that multiple charges are placed across the number line on the x-axis. Okay, into this question you can see, let us say this is the number line. Okay, and on this number line this is plus x and this is the origin. This is the origin 0, right? This is the origin, right? So let me read out the question first. Into the question it's given that an infinite number of charges each equal to q are placed along the x-axis. That means along the x-axis, those n number of or infinite number of charges are placed, which are placed along the x-axis at certain locations. What are certain locations? That is at x equal to 1. Here at x equal to 1, right? Then 2, then 4, then after that on 8, like that, right? These are the locations of the charges. So let us say the charges are here, this is q, here this is q, here this is q, and here this is q, right? All these charges are placed at a location x equal to 1, x equal to 2, x equal to 4, and x equal to 8, right? And if this is the origin, right, this is the origin, this have been asked that the resultant potential at x equal to 0, that means here resultant potential at x equal to 0 is what? This is the question to us. So my dear friends, here what is the formula of electric field potential? Do you know? Electric field potential, electric field potential can be given as or represented by V, and whose formula is V is equal to 1 by 4 pi epsilon 0 into Q, the charge, divided by R. That means the potential is measured at a place where, which is at a distance, where the charge is at a distance of R from that point. So here you can see x equal to 1 is the first location for the first charge, and this is located at a distance of, tell me, this is 1 unit, right? Similarly, the second charge is placed at a distance of 2 units, and third charge is placed at a distance of 4 units, and fourth charge is placed at a distance of 8 units. So you can see the numbers 1, 2, 4, 8, right? These are following a sequence. Okay, suppose due to the first charge, this is the charge at x equal to 1, this will be creating a potential at the origin of, due to the first charge, it will be equal to 1 by 4 pi epsilon 0 q by r, right? Where r equal to 1. Perfect. Now when this is multiplied by, and due to the second charge, this is the potential due to the first charge, this is by, let me write V, that means potential by q placed at x equal to 1. Here this will creating a potential of 1 by 4 pi epsilon 0 q by r equal to 1. So right, this can be written as 1 by 4 pi epsilon 0 q by 1, which is equal to 1 by 4 pi epsilon naught q by 1, because r is equal to 1, right? Similarly, this is potential generated by the charge which is placed at x equal to 1 here, right? Now similarly, the second one, this will be also generating some potential, and let us say the first is v1. What is this v2? v2, that means potential generated by the charge placed at x equal to 2 at the origin. This charge is creating some impact, okay, and that is the electric field potential generated at origin. So at x equal to what? 2. So here v2, the potential generated by charge placed at x equal to 2, that's why I written v2, okay, that will be equal to again 1 by 4 pi epsilon 0 into q, because all charges are of equal magnitude q, divided by the distance at which the impact is made. So here r equal to 2, right? So it will be into the denominator, it will be equal to 2, right? Similarly, for the third one here, it will be equal to 1 by 4 pi epsilon 0 into q by 4. Why? Because the third charge is placed at a distance of 4 units from the origin, and this will also be creating some potential, and that magnitude is equal to this much, right? So you can see, my dear friends, the total potential at origin will be the potential which is generated by this one, that is v1, due to second charge, that is v2, due to third charge, which this is v3, okay, and at origin. So we need to add all these potentials together, because the magnitude will be added for all. Let us say this is the fourth one, so this is for v4, like that till infinity it is happening, right? So all those potentials will be added, and that will be the total potential, resultant potential at x equal to o, x equal to origin, right? So my dear friend, you not to think any much, you just add v1 with v2 with v3 till infinity, right? So this will be giving you v1 plus v2 plus v3 plus v4 plus dot 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 infinity. This is the resultant potential. So this is the final v, or we can say this is the resultant potential, right? So this is the, let me write 1 minute, resultant potential at origin, resultant potential at origin. Why origin? Because you can see the distance from origin is calculated here, 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 and here, like this, okay? So my dear friends, you just add all v1 v2 v3 and you will get the v resultant. So you can see now the total values into the RHS. Let me write v1. The value of v1 is, you can see 1 by 4 pi epsilon 0 can be taken as common, right? And it will be, for the first it will be q by 1. So when it will taken common, q by 1 will be there into the bracket. That is the value of v1. This is for v1 I have written, okay? Similarly for v2, 1 by 4 pi epsilon 0 into q by, you can see, q by 2 here. This is 2. So it will be q by 2, plus for the third one it will be 1 by 4 pi epsilon 0 q by 4. What I did, I have taken 1 by 4 pi epsilon 0 as common, right? Similarly q by 8 for the fourth one here, like that till infinity, right? So my dear friends, you can see, you can take in fact q from common from all this, okay? Then this will be a geometric progression. Hi Ratan Dev, hello. So here it will be a geometric progression, I'm not able to understand. Is it okay? I'm not able to get your question. So from here, you can see Q can also be taken as common. So this will be giving you, let me squeeze a little. Yeah. So this will be giving you, okay. So total resultant potential at origin, this one is equal to Q by 4 pi epsilon 0 into the bracket, it will be 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus dot till infinity, right? So here you can see all this is a geometric progression. All this is a geometric progression whose common ratio is nothing but GP with R less than 1, where the value of R is equal to, the value of R common ratio here is 1 by 2. You can see B by C by B, B by A, okay, D by C, all are giving a same common ratio. Infinite geometric progression, right, Divendu? Divendu Bhatt, teacher ji, perfectly fine. You are definitely a teacher ji, so definitely you are always right. I am agreeing with you. Thank you. So this will be giving a GP, okay, where R is less than 1, right? Now, yes, A by 1 minus R will be the sum of all this. A by 1 minus R. So this will be giving you, for this sum, it will be A by 1 minus R. That means A over here is the 1. Okay. So 1 by 1 minus R. R is 1 by 2. Right. Will be here, and into the prefix it is Q by 4 pi epsilon 0. So this is the value of, let me write it like this. Okay, I think it was not visible. So this is the equivalent potential at origin, right? This is the equivalent potential at origin. Okay, now I think it's visible. So this will be giving you, when you solve it, you will get the equivalent potential at origin, V origin, as equal to, yes, I think it's visible, yes, 1 minus 1 by 2 into the denominator. So finally half will be into the denominator, so 2 will be going into the numerator. So this will be give 1 by half equal to 2. So this will be giving you Q by 4 pi epsilon 0 into 1 by half, right? So this will be giving you the final resultant potential as, because these 2 going into the numerator, so this will be coming as 2 times Q, right, divided by 4 pi epsilon 0. This is the equivalent potential at the origin by the infinite charges placed at a location of x equal to 1, x equal to 2, x equal to 4, x equal to 8, x equal to 16, like that, till infinity along the plus x direction. And all these charges are creating a potential, creating a potential difference, okay, at a location where resultant potential of the first charge at origin, second charge is also creating someone, the third is also creating someone, fourth is also creating someone at origin. So all these charges are creating a electric field potential at origin, and that was required to be calculated, and our answer is 2q divided by 4 pi epsilon 0, and this is our answer, my dear friends. Okay, so Divendu Bhattacharya ji, thank you so much for your suggestion for the GP. Yes, exactly, 1 plus half plus 1 by 4 plus 1 by 8, all this is geometric progression, and for geometric progression where the common ratio is less than 1. The here we have r equal common ratio as 1 by 2. So the sum will be 1 by 1 minus r, right? So this will help you to calculate the sum of 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 till infinity, and this will be coming as 1 by half, this one, right? So half is there into the denominator, so this will lead to 2 will be going into the numerator. So that's why 2q by 4 pi epsilon 0 is the total potential, is the electric field potential, right? Electric resultant potential at origin by all the charges which are placed at a distance of x equal to 1, x equal to 2, x equal to 4, x equal to 8, like that, right? So thank you so much for watching, my dear friends. I think you got the solution. For any query, just put up into the comment box and be connected. Take care. Bye bye. See you into the next class, my dear friends.